C'est la apprentissage. Keep my eyes upon you are the glorious, immaculate, the beautiful. I can go on and on and on. But my words are not them. My vocabulary is the same. But lead me to cry out. Eva, 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 c'est la apprentissage. Eva, my eyes upon you are the glorious, immaculate, the beautiful. Can go on and on and on. But my words cannot them. My vocabulary is the same. But lead me to cry out. Eva, 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 c'est la apprentissage. Eva, my eyes upon
Hello?
Are you still buying the data?
Oh, no, I'm connected.
You're connected, but you're not calling. So is it connected?
I'm still connected.
you are the glorious, immaculate, the beautiful. On and on.
Hello?
Hello?
Yes, is it connected?
Keep me to cry. Eva,
Morning, teacher.
Good morning to you, Betty. How are you?
I'm fine, teacher.
How was your weekend?
It was boring, teacher.
Boring. Why?
They're taking my phone, teacher.
What happened?
They're taking my phone.
Who is taking your phone?
My parents.
Sorry. So you wanted to stay online during the weekend.
Eh?
Did you want to stay online during the weekend?
Yes. No, they're taking it forever.
Forever, what is it? You are addicted to it.
Exactly.
Why are you
But
addicted?
I don't even how we'll do the online work now, teacher.
You don't know how to do the online.
I don't know how I will do it because now they're taking it.
Have you talked to them? Are they aware that you're attending these lessons?
They know, but I'm using a laptop.
Okay, fine. If you are using a laptop, then you can get the work via the email.
Teacher, you sound funny. Teacher, I want my phone.
This girl with phones. Any hope you convince her to buy for to get you the phone, because if you have a laptop, then in case I was the parent, I would not allow you to use the phone. But the parents maybe think that it makes you unruly.
Maybe.
The phone makes you unruly. That's why they want to take it forever.
Okay, this is serious.
So just need to do what? You should not let the phone control you.
Now, why did they buy it in the first place?
They wanted you to do what? To use it for your research. But now it seems you are too addicted.
Okay, teacher.
Yeah, so it means that you should slow down your addiction for them to return the phone. But in case the addiction goes on, then I'll have to support them to take it forever.
Teacher, you don't know
Hey,
a girl child?
come again.
A girl child.
So the girl child must be connected to the phone.
Yes.
I understand.
Our life depend on it, and it's like they remove one organ from me.
Sure.
Mm-hmm.
Yeah, yes. But now it is just going to be 1 year. Then after that, you'll use it the way you use it. That is after the senior 60, and even at campus, you have all the freedom.
Mm-hmm. Okay, teacher.
Yeah, so that one should not worry you. We'll just take it for a while to make you focus on this candidate class. Then after that, everything will be okay. Tracy, I'm waiting for you. You are not connecting. Tracy, are you there?
Yeah,
Has the internet connection refused? How did you connect yesterday? Do the same the way you connected yesterday. Eh, how are you using the internet? Did you buy the bundles on the phone and creating a hotspot? So which line are you using for data? You're not using any line for data. So how are you accessing the internet? A voucher code. Do you have a fiber at home? A Wi-Fi at home? Okay. So you need to refresh. You need to refresh what? Refresh your either laptop or the internet connection. Because I'm waiting for you. People are already in class. We want to start. Mm. Maybe Betty Akumu is here. She can talk to you and as you connect. Betty Akumu, are you hearing your friend Tracy?
how are you?
Betty? Betty, are you there? Betty. Oh, I think she has just left the phone there. Uh, But do the connection faster because people are waiting for you in the class.
Hey,
Come again?
that's it.
No, the classes start at 8. It's already 4 minutes past. And your teacher is already in class. He wants to start. Mr. Joshua, starting with chemistry. Yeah, so how far have you reached with your internet connection? Mr. Joshua, how is that site?
A very good morning to you all. Hope everyone is doing well. This side is very okay. Maybe that side of yours, but we are
It's
very fine.
yeah, it's good. Welcome back from Rwanda.
Thank you so much. Thank you so much. Though I haven't yet reached that side, but I'm coming.
Still in Rwanda.
I'm this side of Mbarara, but I think by today I'll be there.
Okay.
Yeah, so
So you
my members
enjoyed the
haven't yet popped in.
yeah, Beta Kumo was here, but she has jumped off. Then these others
Uh,
are struggling to connect. I'm calling Tracy now, but
hmm.
work is disturbing her. I think internet is disturbing her.
Okay, let's wait
So
for them.
I want to try to
Mm.
guide and she joins.
Okay. I'm here ready.
Okay, let me make you a what? Cause
Okay.
there is Amanda. Tracy, how far have you reached? Because I don't know what is happening to the internet. Don't you have bundles on your phone? You need to buy bundles on your phone as an alternative if you are waiting for the other one to connect. Just buy some few bundles on your phone, connect. When the other one connects, then you can go back and do it. Use the home fiber or home Wi-Fi. Who is helping you connect? Let him try using a phone. Let him buy some data on a phone and try connecting with it. Just some little data as you wait for the Wi-Fi to connect. Okay. But here, Mr. Center is already there, Mr. Joshua. They are all waiting for you, including your friend Nama, and you are not connecting. People are waiting for you. But I think Mr. Joshua is about to start even. So have you bought, is he buying data?
Right.
You buy data.
Mr.
Mr.
Wanan,
Center, Mr. Center, yes, your daughter is here.
what is good morning, Mr. Wanan?
Good morning to Mr. Center.
I'm good. What is the issue?
There are very many issues. Have successfully created an email, but now the other issue is that she's not yet connected to the internet. I think the data she bought is not working. I mean, the voucher she bought, she's using a home Wi-Fi. It's not working yet.
But that home Wi-Fi has been on for some time. Then how come
Mm.
is it not working?
Let's pray for her. Let's just pray for her.
We pray. That
You
one
pray
is
for
finished.
because now things are not.
Okay, I think that one we are going to solve.
Mhm.
Time is moving. It's now like 10 minutes after.
Yeah.
Mr. Joshua, are you on? Okay. Is Mr. Joshua really on? I'm seeing him online, but
He- He's on. He's just waiting for people to join.
hey,
Sentai,
Yeah.
morning.
good morning to you, sir.
How are you, sir?
Well, I'm good. We'll be back, man.
Thank you, thank you. Hope you reached well that side.
Yeah, I reached well.
Mm.
Yeah. Time we have here two guys. There is this
See,
one called Catherine
mm,
and this one from Nigeria, Amanda. So you normally I'm going away. You can start with those guys. Even this one from Budadiri has come. So you guys have a nice lesson.
God.
okay. From Budati.
So Tracy, have you bought the data? Let me first mute my microphone here. Oh, sorry. I've muted Mr. Joshua's microphone instead of mine.
Okay, so a very good morning to those who have not been around, who have just joined in. Let me hope everything is okay. Everything is okay. Right now, we are going to continue with our experiment. So the other time, we were looking at the other graph, which had the variation of vapor pressure of the pure solvent and that of the solution with the temperature. So we saw those two graphs, how they are basically taking place, or how they are basically varying. Little bit. Okay, so I was saying that the other time we were looking at this graph right here, the one of elevation boiling point. So we interpreted all that graph. So for those who are not around, please make sure you read it very well. So we also talked about the boiling point constant, or what we call the ebullioscopic constant. And we defined it as an elevation in the boiling point, which is caused when 1 mole of a non-volatile solute is dissolved in 1,000 grams of a solvent. The solvent can be water, it can be carbon tetrachloride, it can be any solvent, so long as it's a solvent, it can dissolve a solute. Then we talked about that elevation boiling point as DTB. We summarize it as DTB, or that is change in the boiling point. So that elevation boiling point, DTB, elevation boiling point, which we call DTB, depends on the number of moles of solute particles, of non-volatile solute particles in the solution. When the number of non-volatile solute particles in the solution increase, that basically also means that the elevation boiling point, which we summarize as DTB, will also increase. So then we talked about that elevation boiling point constant, the elevation boiling point constant. So the elevation in the boiling point constant, or that boiling point constant elevation, that one we call it Kb. That is Kb. You can call it not the other Kb of ionic in ionic chemistry or in ionic equilibria, but this one is called Kb, like as we're going to be looking at it. So what you have to understand here, it is the elevation boiling point constant, which we call a ebullioscopic constant, Kb, and that DTB. DTB is elevation, that is just elevation boiling point. That's DTB. Then Kb, that is elevation boiling point constant. So that one is always a constant. So we define it as just an elevation which is caused when 1 mole of a non-volatile solute is dissolved in 1,000 grams of a solvent. So that one, you have to understand them. And we said all of them, they basically depend on the number of solute particles that are within the solution. Now, right this side, we are looking at an experiment which you can use to determine the molecular mass of a non-volatile solute using the boiling point elevation method. Like these colligative properties we have talked about, they can enable us to get molar mass of different solutes, of those non-volatile solutes we add in those solvents. If you add non-volatile solute X, you don't know its molecular mass. You can use elevation boiling point method. You can use a freezing point, freezing depression, freezing point method. You can use osmotic pressure or even vapor pressure lowering to easily come up with the molecular mass of that non-volatile solute. So here we are looking at an experiment which someone can use to get the molecular mass of the non-volatile solute in the solution. So how best can we get it? Now here we use what we call the Cottrell's apparatus. The Cottrell's apparatus is designed in the way that it has what we call the Beckman's thermometer. What's the importance of the Beckman's thermometer? That one is to measure temperature changes. Remember, you have to measure the temperature of the pure solvent itself. You get to know the boiling point. You get to know at what temperature does the pure solvent boil. After knowing the boiling point of the pure solvent, you add the non-volatile solute. You also measure the boiling point of the what? Of the so-called solution. But right now here in the Cottrell's experiment, we have this Beckman thermometer. Its major importance is basically to measure temperature. The thing should be to measure temperature. So after measuring the temperature, that's temperature of the pure solvent and temperature of the solution, then you can get temperature change or you can get elevation in the boiling point. So we have the Beckman's thermometer. Then we also have now we have a container, that's a wide one, which has a condenser. So we have that wide tube. We have two tubes. We have that wide tube, which wide tube is made up with the side arm. So we have the wide tube, which has the side arm. And it is that side tube which has the solution or which has the solvent. Which has the solvent or the solution. It can be solution, it can be solvent, depending on what you have put there. So it has a side arm. The importance of the side arm is to allow you to add there the solute particles or the non-volatile solute particles. That's the importance of the side arm there. Yes. Then another part, it is the inner tube. So from the wider tube, we have the inner tube. The importance of the inner tube, as we are going to see it, that inner tube is also there.
Kathy, nauza. Petronella, Morris, Edgar.
Yes.
Aha, thank God. So,
Mm.
Petronella, did you do the graph work?
Nope. But okay, maybe like an example, but not the exercises.
Mm,
Mm.
okay.
Yes. But
So how
now
is
what
your
happens? The graph.
mm,
I'm still confused on it. Mm.
okay.
Guys,
Because
How is your holiday?
it's fine.
Okay.
It rains.
For us, we are in the desert.
Wow.
Namanda,
Mm,
what's going on?
I don't know, but Mr. Joshua has gone off.
Why continue the music?
No, 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 no.
Guys, bring some numbers. Did you do the numbers in Demystify?
Yeah, I did the graph work. Maybe I can be presenting that and see if you guys have the same answers. If not, you give me the correct answers.
Mm.
I also did it.
So
I
is
did
it
it
okay?
last.
Let me see if I can share my screen. I
You can't
cannot.
share a screen.
Mr. Wanyonyi is
It's
not
only
on.
the host.
What
Yeah,
happened to Mr. Anyoni?
I even don't know.
It's only the host who can do that.
So what are you trying
Members,
to do?
what is happening here?
Mr. Wanyonyi,
Tell me.
uh, since Mr. Joshua is not on right now.
He's joining. He has joined.
Eh,
Yes.
okay.
I don't know what had happened, but I just came and found you people making noise and shouting. Okay, Mr. Josh is there.
Teacher, we were not shouting.
Please, ministers, can make me a co-host again. Network this. Add
Mr.
some
Josh, how
network.
are you?
I'm good. How about you, Petronella?
I'm fine.
Yeah. Sorry, I had some network disturbance right here. Someone had called, and as someone calls right here, and I'm using a phone. Okay, so
Mr.
I
Joshua,
think we can. Yes.
And teacher, we did the graph work. Now, how are we going to see if our work is correct? Because for me, I've put my work in the group, but I think you've not seen it.
Oh, I'm going to cross check and I look through the work. I'll comment and I'll try to mark it.
Okay.
Teacher, mine is in your inbox.
Okay, it is fine. I'll find it. Let me first share this document and we start again. Okay, so I was trying to say that those who have tried to do the graph work, I'm going to cross check. I'll mark the graph and I'll try to comment. Yeah, so those who haven't yet, still try and send it in my inbox, or you can put it in the group. Yeah, so we are now writing. So we are still talking about this experiment. So I was saying in this So I was trying to talk about the experiment itself, or the apparatus itself, which we call the Cottrell's apparatus, where we are having the so-called inner tube, where we are having the wide tube, and in the wide tube, we have placed there the solvent or the solution. We have the platinum wire, which platinum wire is connected to the Cottrell pump. So in the Cottrell pump, that's where even the bulb of the thermometer fit, and then you have that Beckman thermometer passing through the so-called inner tube. Now, what happens during this method when you want to determine the molecular mass of a solute using boiling point elevation method? What happens is that we are going to get a known mass of pure propanol. Now here we have used the propanol as our what? As our solvent. So you're going to get a known mass of pure propanol, for example, X grams. We place it in a wide tube. That wide tube we have talked about, which has the side arm. So we're going to get our propanol. We get known mass of it. We place it in that wide tube. But now our propanol is our solvent. So we have measured the grams of the solvent as X grams. We have, okay. It is fine, it's okay. Hope now here you can have. So we are saying we have placed some grams, which are the X grams of the propanol, which is our pure solvent. We have placed it in a wide tube. Then we fit the wide tube with the side arm. Now, after putting those grams of the solvent, what are you going to do? The boiling tube is going to be closed, stoppered, and then we are going to pass there an inner tube, or we are going to pass the inner tube through that wide tube. So when we pass there the inner tube, we are going to open at the lower end of it. like the lower end of the inner tube is going to be opened. Now, once it is opened, we are going to fit even there a Beckman's thermometer in the inner tube. So we are going to pass the inner tube through the wide tube. Then we open, or we make the inner tube at its lower end, we make it open. Then we put there the Beckman's thermometer also in the inner tube. Now, after doing that, we are going to put the Cottrell pump together with the platinum wire in the solvent or in the propanol. So the Cottrell pump together with its platinum wire, they are going to be put into the solvent. So what is going to happen is that the propanol is then going to be heated. Now remember, in the liquid, once the Cottrell pump is immersed there, it is there to prevent superheating, like because the liquid can be superheated. So to prevent superheating, we are going to put there the Cottrell pump, see, to prevent that superheating. But now, when we start heating our liquid, we are going to record the temperature, which is constant, like the temperature at which this liquid boils, and that temperature is supposed to be constant. So we are going to heat our propanol, and as we are heating the propanol, this propanol or this solvent, we are recording the temperature right from the Beckman's thermometer. So when we record the temperature right from Beckman's thermometer, the temperature we are recording from there, it's the boiling point of pure propanol. So when you reach the boiling point of pure propanol, that's when we are going to say that, when we heat and reach that temperature, that's when I'm going to say that you have the boiling point of the pure solvent, TB naught. So the propanol, we are going to heat it. As we are heating it, the thermometer is measuring the temperature. So by the time propanol boils, we would have recorded our temperature as TB naught. So TB naught, we are recording it from the thermometer as the temperature of the pure solvent, which solvent is propanol. So what do we have here? We have the grams of the solvent, X grams. We have the boiling point of the pure solvent. We have also obtained it. Now, what are you going to do? Remember, we were just dealing with the solvent only. Now, what you're going to do is to add a non-volatile solute into this solvent. So, which non-volatile solute are we going to add there? Now, this one, we used benzoic acid. So, we are going to say a known mass of benzoic acid, Y grams. They are going to be placed into the solvent via the side arm. So we are going to get our benzoic acid, and we are going to measure a known mass of it. We can measure 10 grams, we can measure 8 grams, we can measure whatever grams you want. So you are going to measure those grams, and then we add them into the solvent. But how do we add them into the solvent? We are going to use the side arm, which is on the wide tube. Since the wide tube has that part, that side arm, where we can pass our solid, so we are going to get our benzoic acid, which is the non-volatile solute. We put the non-volatile solute into the side arm. The side arm will take the non-volatile solute into the solvent or the propanol. So this benzoic acid, because it is non-volatile, it is going to occupy some of the space on the surface of the propanol. So we are going, after adding them there, as our Y grams. Now those are the grams of the non-volatile solute. We are going to heat this. So now remember, you have formed the solution after adding there the solute. So because you have formed the solution after adding the solute there, now we are going to say a known mass. The resulting solution is going to be heated now also, because you have formed the solution after adding a non-volatile solute. So the resulting solution is going to be heated. It is going to be heated until the Beckman's thermometer shows a constant temperature change. So the constant temperature change, which is going to be recorded right from the Beckman's thermometer, is what we call the boiling point of the solution. So that boiling point of the solution It is not TB naught, but it is only TB. So it is TB degrees Celsius. That's the boiling point of the solution. The grams of the non-volatile solute we added, they are Y grams. The boiling point of the pure solvent we recorded as TB naught. The grams of the pure solvent, they were X grams. So you can see that right from here, we have got the grams of the pure solvent. We have got the boiling point of the pure solvent. We have got the grams of the solution, so the grams of the non-volatile solute, and we have got the boiling point of the solution. Now, after recording those, we come to treatment of results. Remember, our target is to get the molecular mass. How best can we get the molecular mass? So we are going to record what we have obtained right from our experiment. We have mass of the solvent, yes. Mass of the pure solvent, those are X grams. We have mass of the solute or the non-volatile solute, yes. Mass of the non-volatile solute, they are Y grams. We have recorded them, and they are the one which we passed via the side arm into the wide tube, which has the solvent. So mass of the solute, they are Y grams. Boiling point of the pure solvent, we recorded it as what? TB naught, if you remember that. Boiling point of the solution, we recorded it as what? TB. So because we have boiling point of the pure solvent and the boiling point of the solution, we can get elevation in the boiling point, which we call the TB. So how can we get elevation in the boiling point? We say the TB, or elevation in the boiling point, is got by getting the boiling point of the solution minus the boiling point of the pure solvent. So how do we get elevation of boiling point here? Our dTB in the treatment of results will be TB minus TB naught. Because TB is the boiling point of the solution, TB naught is the boiling point of the pure solvent. So that's how we are going to get our elevation in boiling point, that the TB. Then we already know that Kb is a constant. So we also write it here. And we say the boiling point elevation constant is what? The boiling point elevation constant is Kb. That one is a constant. You should be knowing it. You don't need it obtaining it. But that one you should always be having it. And what we know, that Kb is always in 1 mole of a solute, because we add 1 mole of a solute in 1,000 grams of water, of a solvent. So K is always for 1 mole of a solute, which is added in 1,000 grams of the solvent. So you can see that we have whatever we want. We have elevation in the boiling point. We have that is elevation boiling point in the TB. We have the boiling point constant K. Then we have the grams of the solvent together with the grams of the non-volatile solute. Now, how do we use them to get molecular mass? Now, this takes you back to the definition of molecular mass. What is molecular mass? Molecular mass is that mass which is contained in 1 mole of a substance. So which means we are looking for the mass which is in 1 mole of the non-volatile solute. But we already know the elevation which is caused by 1 mole of a non-volatile solute, because Kb is, okay, here we don't know it, but we are going to use it as C. We are going to say elevation boiling, our elevation boiling point constant Kb is C. So that C can be any value, 5.1, 5.3, 5.12, depending on the solvent. So now, what are we going to start with? We start with converting the grams of the solute we have into 1,000. We are going to say, okay, the 1,000 grams. So now here it's like okay, it's summarized. But what do we say? We say, what are the grams of the solvent we have? what we are trying to say is to convert the grams of the solute into 1,000. So we are going to say the y grams of the solute. No, not y grams. We're going to start with x grams of the pure solid propanol. X grams of propanol dissolve y grams of non-volatile solute. I don't know whether you're getting that statement. It is not here, but it is what you're supposed to do to get to this here. X grams dissolve y grams of the solute. What about 1,000 grams of propanol dissolve how many grams of the solute? So that's what I've said. We start by converting the grams of the solvent into 1,000. So we are starting with X grams of pure propanol. They were dissolving how many grams of the solute? Y grams. What about 1,000 grams? Why do you need to go into 1,000? Because you are going to use KB. Are we together? Because, yeah, the step is there, sorry. Because we are going to use KB. Yeah, the step is there. X grams of propanol dissolve Y grams of benzoic acid. What about 1,000 grams of propanol dissolve how many grams of benzoic acid? So I was explaining, why do we need to convert our grams into 1,000? Because you are going to use KB, that elevation boiling point constant. Yet we know KB is that elevation which is caused by dissolving 1 mole of a solid in 1,000 grams of a pure solvent. So that's why we have to make sure that the grams of the solute we are using, they are also in 1,000. So from there, after getting those grams, now we come here and we say, okay, after getting the grams in 1,000, grams of the solute in 1,000, we are going to say, the elevation we have, remember we said we can get the elevation in a boiling point. How do we get the elevation boiling point? We recorded our temperature of the pure solvent and the boiling point of the solution. So we can get the TB, but the elevation in that elevation, the boiling point, is caused by those grams in 1,000 you have got. Is that okay? We say the elevation in the boiling point, the TB, which is got by getting the boiling point of the pure solvent, of the solution, take away the boiling point of the pure solvent. That elevation in the TB is caused by how many grams? By those grams of the solid which we have just got from 1,000. That's why you are bringing that expression back here, 1,000 times y over x. The one we have obtained here, because we don't have a calculator. The ones we have obtained right here down. So because after doing this, that you want x grams of that dissolve y grams of benzoic, what about 1,000? We are getting 1,000 y over x as the grams of benzoic in 1,000, or as the grams of the solute in 1,000. So after getting those grams, these grams we have got here, they are caused by the other elevation, they cause the other elevation in the TB. So that's why here, when we come right here, we are saying the TB, when I talk about the TB, get to know how to get the TB. The TB is the elevation in the boiling point, caused by how many grams? By those grams you have got in 1,000. That's why we are bringing the expression here, caused by 1,000 y over x grams of benzoic. What about Kb? Remember, Kb is the elevation caused by 1 mole, and we need molecular mass. If we can get the grams which causes Kb, then we have got the molecular mass direct. So we are saying the TB, that is the elevation, the boiling point, caused by those grams of benzoic or non-volatile solute in 1,000. What about Kb? Remember, Kb is a constant which is known, and whichever question will be given to you, they will give you that Kb, unless when the question itself is asking for Kb. But if the question is asking for molecular mass, Kb will be given. So what about Kb? Kb is the elevation, the boiling point, caused by how many grams? So you get Kb times the other expression in which we have 1000 y over x over dt. So that thing you are going to get right from there is what we call the molar mass of the non-volatile solute. So there are around 2 steps. The moment you summarize down and you get your DTB, you summarize the information. Do you have the boiling point of the pure solvent, boiling point of the solution? Can you get DTB? Some question may not give you the boiling point of the pure solvent and the one of the solution, but it will directly give you the DTB. But in others, they will give you the boiling point of the solution, boiling point of the pure solvent, such that you can calculate the DTB. But some other question will just give you DTB direct. That DTB is caused by the grams of the non-volatile solute in 1000. That's why you have to convert the grams of the non-volatile solute into 1000. So you tell us these grams of the solvent dissolve these grams of the solute. What about 1000? That's the first step. After getting the grams of the non-volatile solute in 1000, you come and tell us the DTB is the one which caused, DTB is the elevation caused by those grams of the solute in 1000. What about Kb is caused by how many grams? The grams you get is the molecular mass. Why? Because Kb is caused by 1 mole of a solute, and that 1 mole is in molecular mass. So that's why we directly conclude that the grams we are getting from the elevation as Kb is the molecular mass. Okay, so hope we have all understood that experiment. We need the molecular mass. We need to use that experiment. The reason why we need the other apparatus is basically to obtain the what? The boiling point. Now someone is asking, is it DTB or DT? You can call it what you want, but it becomes better when you call it DTB. Because even if a freezing point it is there, we call it DTF. Yeah, so you can call it DT or DTB, but it is better. Because when you use that word, it is better. Doesn't mean that the other one is wrong. Yes. So it is better you call it DTB instead of DT. But if you are using DT, it is okay. It is very, very okay. So long as you understand that it means elevation in boiling point. So long as you get to understand that it means elevation in boiling point. So whether you use DT or DTB, it's okay. So long as you understand its meaning. Okay. So the limitations of elevation in boiling point, they are the same as those of other colligative properties. That one I talked about it. They are the same. So why do we say that they are the same? Just look at them. Solute does not associate or dissociate. The solution should be dilute. There should be no chemical reaction between the solute and the solvent. The solute should be non-volatile. So they are the same. You just need to understand them. Then they apply for both, for osmotic, depression, freezing point, elevation, boiling point, and even for vapor pressure lowering. So they are the same. We don't need to repeat those ones. And their explanations are also known. The other time I was explaining dissociation and association. I explained the, I think, association, we explained the dissociation. So these other ones are very easy to understand. When the solute dissociates, the number of particles in the solution increase. Once they increase, the colligative property will also increase. Once the colligative property increases, then the molecular mass will decrease. When association takes place, the number of particles will decrease, colligative property will increase, the molecular mass will increase, because molecular mass is inversely proportional to the so-called colligative property. So that's why when the colligative property decreases, molecular mass increases. When the colligative property increases, molecular mass decreases. Yes. So that's why you'll find that question which says, anyway, we'll look at it in osmotic pressure, which require to use that explanation. But what you have to know that colligative properties are inversely proportional to molecular mass. And we know colligative properties increase with increase in number of solute particles. The more the solute particles increase in solution, the more you increase the effect on the colligative property. And the more the colligative property is affected, then you lower the molecular mass. But when the number of particles in the solution decrease, the colligative property will decrease, then the molecular mass will increase because it is inversely proportional to the those colligative properties. Anyway, so I think we can go direct to our calculations. This one we're explaining okay, so the first one, that question, we have it there. The first example, a solution containing RCOOH, that is a carboxylic acid, yeah? Containing that carboxylic acid, and 50 grams of water was boiled. I hope you are noting something. The 60 grams are for the ethanoic, for that acid. So not ethanoic, it can be any carboxylic acid, RCOH. It's for a carboxylic acid and 50 grams of water. So we have 50 grams as the grams of the solvent. We have 60 grams as grams of the carboxylic acid. What do they want? The question is saying, calculate the boiling point of the solution. But do you remember the boiling point of the solution? It is TB, boiling point of the solution. But how can we get the boiling point of the solution realistically? The only way we can get boiling point of the solution is when we know the boiling point of the pure solvent and the elevation in the boiling point. Because the TB equals to TB minus TB naught. But what we want is TB. Do we have TB naught? Do we have the TB? The truth is, we do have the TB naught is known. Why? Because we are using solvent as water. The boiling point of water is 100, so TB naught is known. What is not known is the TB. For us to get TB, or the boiling point of the solution, we have to be with the TB, the elevation in the boiling point, such that we can get the boiling point of the solution. Because the boiling point of the pure solvent is known. So we'll use that formula, the TB equals to TB minus TB naught. So since we have the TB naught as 100, can we get the TB, the elevation in the boiling point? Yes, we can get it. How? So we are going to go back in our calculation and say 50 grams of water dissolve 60 grams of a carboxylic acid. What about 1,000 grams of water dissolve how many grams of a carboxylic acid? That's the first step I told you about. You first convert the grams of the solute into 1,000. So we have converted 50 grams of the solute, of water, dissolve 60 grams of what? Dissolve 60 grams of carboxylic acid. What about 1,000 grams of water? Dissolve how many grams of the carboxylic acid? So you have got 1200 grams of the carboxylic acid. Are you together? So, but our target is to get the TB. After getting the TB, we use it to get TB. Hope that thing is flowing. We need the TB, boiling point of a solution. But you can get it when we have the TB and the TB naught. But the TB naught is known as 100. What we don't have is the TB elevation boiling point. So how can we get elevation boiling point? In the bracket, they gave you Kb of water as 0.54. But Kb is in how many grams? Kb is in how many grams? Kb is supposed to be the molecular mass of the solute. Do we know the molecular mass of the solute? So, the molecular mass of the solute, remember the solute is RCOOH. But in the bracket, they have said R is 43, H is 1, carbon is 16, oxygen is 16. Sorry, carbon is 12, oxygen is 16. So, which means we can get the molecular mass of the solute. But that molecular mass is caused by Kb. So it's the one which causes Kb. I don't know whether you can get me now that you can get the TB. So after knowing that you can get molecular mass, so I'm going to say molecular mass of the carboxylic acid is 43 plus 12 plus 32 plus 1, which is 88. After getting our molecular mass, we're going to say this molecular mass is the one which causes Kb, which is 0.54. Because we said Kb is caused by 1 mole. And that 1 mole, of course, it is in the molecular mass. So the 88 grams of the carboxylic acid are the one which causes Kb, which Kb is given as 0.54. Is that okay? What about the other grams we have got, 1200? They are caused by which kind of, so they cause which elevation? So what about 1200 grams of the solute? Cause which elevation? So the elevation you are going to get there is the dTb. So after getting your dTb, then you get it and you use it in the other formula that the TB equals to TB of the solution minus TB naught of the solvent. Because you have the TB, which is 7.3636, and the boiling point of water is 100, you are going to add them together, and the boiling point of the solution will be 107.36. Hope that one is very okay. The question had given you the mass of the solvent, the mass of the solute. You needed to convert them into 1,000 to know the mass of the solute in 1,000. After knowing the mass of the solute in 1,000, the question is asking you to get the so-called boiling point of the solution. And the boiling point of the solution, we said you can get it by using the other formula, the TB minus TB, sorry, the TB equals to TB minus TB naught. But TB naught is the boiling point of the pure solvent, yet our solvent is water, and the boiling point of pure solvent is 100, because that is water we have used. And we said you don't have the TB. How can we get the TB? We said you can get the TB after knowing the grams in 1,000. Since we have Kb, we say the molecular mass of the solute is the one which is the one which causes Kb. So Kb is given as 0.54. So we just say the 88 grams, which is the molar mass of the solute, they cause this Kb, which is 0.54. What about these grams I've got in 1,000? They cause which elevation? That elevation is the dTb. After getting your dTb, you go back to your formula. dTb equals to TB minus TB naught. Then you get the TB, or the boiling point of the solution. So you can see that the calculation was very, very easy. Okay. Assumptions, those are the same. The salt should not dissociate or associate. The solution should be dilute. The solute should be non-volatile. There should be no chemical reaction between the solute and the solvent. Okay, so we go to another question. Question 2. A 2% aqueous solution of urea. Are we together? I told you how to interpret that statement. A 2% aqueous solution of urea has a boiling point of 100.08 degrees Celsius. So what? I don't know whether we are seeing each other there. Full stop. Calculate the boiling point of pure water. Kb for water is 0.52. How can we calculate the boiling point of pure water? Still, when we have dTb, I don't know whether you are seeing me. Then now, this time round, they want boiling point of pure solvent. The other part, in question 1, they wanted the boiling point of the solution. Now, right here, they want boiling point of the pure solvent. But still, we can get it when we have dTb. But how do we get dTb? The first step is always the first step. We convert. But we don't know the grams, but they have just said a 2% solution of what? Of urea. That means in that solution, there is a 2% urea. 98% is water. So what does it mean? We have 2 grams of urea in 98 grams of water. So therefore, we are going to say 98 grams of water dissolve 2 grams of urea. What about 1,000 grams of water dissolve how many grams of urea? So we get the grams of urea in 1,000. But we need the TB. That should be in your mind. After getting the TB, we get the boiling point of pure water. Now come here and see. They gave us the boiling point of the solution. They gave us Kb again as 0.52. But we know Kb is caused by the molar mass. Can we get molar mass of urea? Yes, the formula is given. CON2H4. So we are going to get the molar mass of urea. After getting molar mass of urea, we are going to say, these grams you have got, the 60 grams of urea, they cause Kb, which is 0.52. What about the 20.40 grams of urea, which are in 1,000? They cause which elevation? That elevation is called the TB. The same statements we made up in question 1, they are the same statements we are making here. The 60 grams of urea, which is the molar mass, cause Kb, which is 0.52. What about these grams you have got, the 20.40482? Those grams, they cause which elevation? That elevation is the so-called dT or dTb. After getting it, we need boiling point of pure solvent. How do we get boiling point of pure solvent? What we are going to do is to get the TB using our formula. The TB equals to TB minus TB naught. What we want is TB naught. The question gave us TB or the boiling point of the solution as 100.08. So we are going to put our 100.08 where there is TB. Take away TB naught, which you don't know, equals to the TB. So since you have the TB as 0.1769 and you have the TB of the solution, you can easily get that TB naught. So from there, it is very easy. So you can see that the question was also simple. Now, in fact, in all the question, the first step is converting those grams you have into 1,000. Okay. So then look at another calculation. So now look at this other calculation. 2.0 grams of phosphorus. Now what is phosphorus? 2.0 grams of phosphorus raise the boiling point of 37.4 grams carbon disulfide by 1.003 degrees Celsius. By the way, when you are reading, make sure you understand the information in the question. 2.0 grams of phosphorus raise the boiling point of 37.4 grams carbon disulfide by 1.003 degrees Celsius. What is that? Someone should reply me. What is 1.003?
Teacher, it is the
Yes?
elevation. It is the elevation in boiling point.
It is the elevation in the boiling point, which we call the TB. So that's why I told you. In some questions, it will be given the TB direct instead of the other boiling points. You can be given the TB direct. So they have told us that 2.0 grams of phosphorus, they raise the boiling point of 37.4 grams of carbon disulfide by 1.003. So that means we have the TB already. Now, what are they saying? Calculate the molar mass of phosphorus in carbon disulfide. But you know molar mass is in Kb. Molar mass supposed to be in Kb. Is Kb given? Yes. Kb for carbon disulfide is 2.35. So we start. Our first step, we convert 37.4 grams of carbon disulfide, which is the solvent, dissolve 2.0 grams of phosphorus. What about 1,000 grams of carbon disulfide? Dissolve how many grams of phosphorus? 53.475. So you have the 53.475 grams of phosphorus. Yes. But those grams are the one which are responsible to cause the other DTB, because they told us that 2.0 of phosphorus raised that boiling point by that. Now what are we going to say? We are going to say the elevation, which is 1.003 degrees, is caused by 53.4759 grams. What about 2.35? Remember, 2.35 is the Kb, and what you want is the molecular mass. Which molecular mass is supposed to be in Kb, because Kb is caused by 1 mole. So there, we are saying our DTB, which is 1.003, is caused by how many grams? 53.4759. What about Kb, which is 2.35? For it, it is caused by how many grams? Which is 125.29. That's the molar mass of phosphorus. So after looking at that, after getting the molar mass of phosphorus, you can see how it was very easy to get. We have converted our grams into 1,000, and after converting them into 1,000, we have used the boiling point. We have used the boiling point, and now we have used the Kb to get the what? The molecular mass. What is B is saying, okay, after you getting the molar mass of phosphorus, can you determine the molecular formula of phosphorus? So now what you have got is the molecular mass. So assume we don't know the formula of phosphorus. We are going to, if you remember how we did with the tin, it was a tin, I think. Was it tin? No, it was sulfur. It was sulfur. We wrote it as Sn and we equated it to molecular mass. So the same thing here, because we need the molecular formula of phosphorus, we are going to write it as Pn equals to molecular mass, which you have got. So Pn will be equal to what? 125.29. So you get the value of N when it is 4. So you can easily get the molecular formula of phosphorus as P4. So therefore phosphorus is tetraatomic. Okay. So that one was also very, very simple. So in fact, in whatever question we're going to do right here, you need to convert these grams of the solute into 1,000 grams of the solvent. Okay. So then question 4. Question 4, I think I'm going to pass through that one. Someone will take us through another question. I think if you have some other questions. So this one is going to be my last question. So others, if you are going to take us through, because I'm very sure you have done, at least you have done 3, this is going to be the 4th one. So make sure at least you get all the tricks which are in these questions. Now this one is saying 0.900 grams of a solute was dissolved in 100 cubic centimeters of benzene at 25. The solution formed boiled at 0.25 degrees higher. The solution formed boiled at 0.25 degrees Celsius higher than the boiling point of benzene. Calculate the relative molecular formula of solid mass of the solute. Our solute is what? We don't know it. They have just said solute. What we know is our solvent, which is benzene. So what are you going to say? We are going to say we have the grams of the solute already as 0.9. Because we have the grams of the solute as 0.9, do we have the grams of the pure solvent? Yes, we can get them because they gave us volume instead of grams. And we already know this, how best we can convert volume into grams. We use density. The density of benzene was given as 0.879. So what we are going to do is to get what you have to do is to get the what? The density. After getting the density, you multiply it through the 100 cubic centimeters to get the grams. So that's how you get the grams of the solvent. So that is going to be your first step. To get the grams of the solvent, we are going to get 0.879. 0.879 is the density. You multiply it through by 100, which is the volume. What you are getting is the mass of benzene, which is 87.9. After getting the grams of benzene, now we are going to convert to 1,000, the way we have been doing it. How have you been doing it? The 87.9 grams of benzene dissolve 0.9 grams of the solute. 87.9 grams of benzene dissolve 0.9 grams of the solute. What about 1,000 grams of benzene dissolve how many grams of the solute? So that's the only thing there. After getting the grams of the solute in 1,000, then you are going to tell us that 0.25. Remember 0.25, it was the elevation boiling point, because they said the solution formed boiled at 0.25 degrees Celsius higher than the boiling point of benzene. So which means what they gave you is the boiling point elevation, the TB. So that's what they gave you there. Okay, so that's the boiling point. So the boiling point elevation, dTb is 0.25. So that 0.25, that elevation causes sorry, it is caused by how many grams? The 0.25 degrees Celsius, that elevation boiling point, is caused by 10.2389 grams. All of us, we can agree. What about the Kb? Because Kb was given as what? 2.52, because they said molar elevation constant. Now, instead of them telling you Kb, they just say molar elevation constant, but that is Kb because it is in 1 mole. Remember, we need the molecular mass. So what are we going to do? We said 0.25 degrees, that elevation, the TB, is caused by 10.2389 grams of the solute. What about Kb? Kb is 2.52. That elevation is caused by the molar mass. So what you get there is your molar mass. So the question had nothing like a trick, just that you had to first convert the other volume into grams by using density. After getting the grams using density, you convert normally from the other grams of the solvent into 1,000 grams of the solvent. After getting the grams of the solid in 1,000 grams of the solvent, those grams are the one which causes the TB. So you are looking for molecular mass, you have Kb. So you tell us that the TB is caused by those grams in 1,000. What about the Kb is caused by how many grams? So what you'll be getting is the molecular mass. Okay. Now, I want someone to take us through now this calculation here. So yeah, I think you should. Someone should take us through that one. Okay. So who can try to take us through this based on what you have just talked about? I'm very sure at least there are a lot of stuff. So there are a lot of numbers we can write down. So when you look at question 3, so this other question would have been question 5, was poorly labeled. When you look at that one, which is supposed to be question 5, they are saying the boiling point of water is 100 degrees Celsius. But when 1.97 grams of potassium chloride is dissolved in 125 grams of water, the solution is boiled at 100.11 at a pressure of 760 millimeters of mercury. They are saying explain this observation. Then after explaining the observation, they are saying calculate the boiling point constant of water. The boiling point constant is Kb. That's what they want. Can someone take us through that? We have done 4 examples, so this is the 5th example. Can I have a member who can? Okay. For the case of explanation, that one I think it is the same as the other side. When we are looking at elevation, you add the potassium chloride, which is a non-volatile solute. Adding it there, it covers some of the surface. It covers the surface of the pure solvent of water, reducing the escaping tendency of the solvent molecules into the vapor phase, which reduces the vapor pressure exerted on the liquid, and then resulting into a reduced what? Reducing the vapor pressure above the liquid. Therefore, for boiling to take place, the solution should be heated at high temperature such that enough vapor pressure can be created to equilibrate with the atmospheric pressure. But now, this other part, how can we calculate the boiling point constant, Kb? The calculation is already there. I just need someone to take us through who can explain that calculation based on what you have been given and what you are looking for. Yes? No one is taking us through that one? Okay, when you look at this calculation, there's nothing new here. Everything we talked about is there. Look, what do they want? They want Kb. But Kb is supposed to be in molecular mass. My question would be, can you get the molecular mass of the non-volatile solute? Yes, because the non-volatile solute is potassium chloride. So you can't fail to get molecular mass of potassium chloride. Kb is caused by molecular mass. By the way, when they ask you such question, you have to understand what's the directive of getting it. You need Kb. I can get it from molecular mass. I need the molecular mass. I can get it from Kb. So now this question requires us to get Kb. And yet Kb is that elevation caused by the 1 mole in what? Of a solute, which is the molecular mass. So what I'm going to first think of is getting molecular mass of potassium chloride because it is my non-volatile solute. So right here, when you look at the question, they gave us the boiling point of the pure water, they gave us the grams of the pure water, and they gave us the grams of the potassium chloride with the boiling point of the solution. So which means they want us to first get the TB. How can you get elevation boiling point? Get TB minus TB naught. What is your TB? TB is the boiling point of the solution. Yet it was given as 100.11. So 100.11 minus TB naught. TB naught is 100. So your dTB is going to be equal to what? To 0.11 degrees Celsius. So the boiling point of the solution and the boiling point of the pure solvent, they were given to you in order for you to get the TB. The grams of the solvent were given and the grams of the solute were also given. How can you really use them? What we are going to say, we have been using them. 125 grams of water dissolve 1.97 grams of potassium chloride. What about 1,000 grams of water dissolve how many grams of potassium chloride? So the grams of potassium chloride you get, they are in 1,000. After getting them, then you come here and say, remember you need the Kb. You tell us, those grams have got the 15.76. They cause the other dTb, the 0.11. So you tell us 15.76 grams of potassium chloride causes elevation of 0.11, which is the dTb. What about the molecular mass of the potassium chloride, which is 74.5, cause which elevation? The elevation you get is your Kb. I think you can see the relationship there. You have the TB. The TB is caused by those grams in 1,000, but you need the Kb. Yet Kb is in molecular mass. So we're going to say the grams in 1,000 they cause that elevation, which is 0.11. The elevation was not given to you direct. You had to find it by getting the TB minus TB naught. That's why we got 0.11. So we are saying those grams, the 15.76 grams of potassium chloride, they cause an elevation of 0.11 degrees Celsius. What about the molecular mass? What about the molecular mass, which is 74.5 grams? You think for it causes which elevation? The elevation you get there is the elevation boiling point constant, which is 0.52, or which is your Kb. So you can see there was nothing like a trick. So everything you needed were there. So you just had to know the steps to follow. So that one I've passed through it. That's the fifth example. The fifth example is down here. I want at least one member to try at least one example right here, because I'm very sure you talked about these things with mental detail. We are just repeating them right here. And you have talked about a good number of examples. So at least you should have, by now, you should have learned, or you have at least got something, and at least you can do one or more questions right from here. So look at that next question. It's supposed to be question 6. Define the term boiling point elevation constant. After defining it, they are saying the boiling point of benzene under certain pressure conditions is 80. The boiling point of benzene that's under certain condition is 80. Calculate the boiling point elevation constant. Still, that is Kb. They want you to calculate Kb of benzene. If the solution containing 5 grams of 2,4,6 trinitrophenol in 100 grams of benzene boils at 80. By the way, this question resembles that one I've just explained. It resembles because here they have given you the mass of the solvent, they have given you the mass of the solute, they have given you the boiling point of the solvent, they have given the boiling point of the solution. So what they want is Kb. So this question is similar to the one which is up there. So I'm very sure at least one member can try and take us through that one. Can anyone try and explain that? How we can get Kb? Yes? Who can try and explain that question down there? Because whatever is there, it is the same things which are even there. The last question I've just explained. So if you have been attentive and if you have read the question, that one is also very easy to attempt. Now, Rizal, are you there?
Yes, teacher.
Okay. Can you take us through that question? That calculation?
I can try.
Okay,
Yeah.
give it a try.
Okay, the fourth one,
Yeah, that one.
the boiling point of benzene under a certain temperature condition is 80.0 degrees Celsius. Calculate the boiling point elevation constant of benzene. If a solution containing 5 grams of 2,4,6 trinitrophenol in 100 grams of benzene boils at 80.568 degrees Celsius. So when you look at this question, it's demanding the boiling point constant the boiling point elevation constant of benzene, meaning they want the dt. Yeah? Yeah, they want the dt, but then we are given the boiling point of benzene
No,
as
they want Kb. Remember, that is a constant. dt is not a constant. dt keeps on changing depending on the solution and the solute. So depending on the solvent and the solute. When they say boiling point constant, the word constant, if it is there, we said that is Kb. dt or dtb, that is just elevation in boiling point, but it is not a constant. So because the question is very specific and it is saying that calculate the boiling point elevation constant of benzene, they want Kb, not dt. However much you are going to use dt or dtb in your calculation as you are trying to get Kb. So be very specific on what to get such that members can get it well.
okay. So a correction there, the boiling point of benzene under certain pressure, boiling point elevation constant of benzene is the one they want. And teacher is saying it's the Kb, and I've also corrected that it's the Kb. So in the first place, we are going to first get the grams of benzene dissolved, the grams of 246 trinitrophenyl in 1,000. So we shall first convert it and say 100 grams of benzene dissolve 5 grams of 246 trinitrophenyl. What about the 1,000 grams of benzene dissolve that? So we get 1,000 times the 5, we divide it by 100. And if you press a calc, you'll get the 50, let me see, 1,000 times 5 divided by 100, you get the 50. So when you get those 50 grams, you first leave it there. When you get our 50 grams, so since they want the Kb, we're told that it's a constant, and that constant is the one we are going to use in our working. And before you get it, you get it from the other formula of dt being equal to tb minus tb of solution minus tb of solvent, and the tb is given in the question as 80.568 and minus the boiling point of benzene is also given as 80.0. So when you subtract, you get 0.568 degrees Celsius, and that will be our dt. That dt is the one we are going to use. In fact, this part of calculating the boiling point elevation constant of benzene, we had to first get the dt, then after that we get the boiling point elevation constant. So we are going to get the molar mass of 246 trinitrophenyl, and if you put it in calculations, you get 229 grams. Yeah. So when you get 229 grams, but remember in the question we have 50 grams. So that 50 grams, the 50 grams elevate by the dt we have got, and the dt is 0.568. I don't know that you're getting 50 grams of 246 trinitrophenyl elevate by 0.568 degrees Celsius. What about the the MR you've got, which is 229 grams, elevate by, then you get 229 times 0.568 divide by 50. So when you press that in your calc, let me see, the answer is here, but then we can't be sure of it because this is just it's not a textbook, it's just a pamphlet. So 229 times 0.568 divided by 50. So the answer is 2.60144. Yeah. Then the decimal places, you can have, teacher, we are not sure yet, but then here I have 2.60144 as the boiling point constant of benzene.
Yeah, that is fine. You can take 2.6 since the next value is 0 from 6.
Okay.
You can just say 2.6. Okay, thank you. Thank you for that. So you just have to try out a number of questions because these questions are very, very many. They are very many. So, and the tricks are not so hard to basically get. You just have to try and get to know that if they trick me in this way, I have to solve that trick in this way. So you just have to practice the questions. So far we have done 60 questions. We are going to end with this 50th question right here. So the rest of the questions that are down here, they are going to be yours for you to try them out because you need to be trying out these questions. I said those who did the graph numbers, kindly send those graphs into my inbox. Or in the group, I'm going to be marking them, or I'm going to mark them, then I comment. So if you have them, just scan them and send them. Make sure you have a cam scan at least in your phone, such that you don't always take a picture. Yeah, when you scan using cam scan, you can easily create the PDF instead of taking pics and send pics. But those who have sent pics, it is very okay. I will mark them. Then we are saying, this one is saying calculate the mass of sucrose that would have to be dissolved in 1,000 grams of water to raise its boiling point to 101.7 degrees. KB is that, oh, this one is very, very soft. Very, very soft. How can we get because the question itself wants us to get the mass of sucrose. But it has given us the boiling point of the solution. The grams of the solvent are also given. So this was very simple. What you need to do is to first get the DTB, or the elevation boiling point, because we have got the boiling point of the solution as 101.7, but we know the boiling point of the pure solvent because our pure solvent is water. So we can get the DTB as 101.7, take our 100, you remain with 1.7 degrees Celsius. But we know that DTB is caused by those grams we are looking for. So what we are going to do is to get the molar mass of sucrose. The molar mass of sucrose, when you use that formula C12H22O11, the molar mass of sucrose is going to be 342 grams. But you know the molar mass causes Kb, that one you know it. So what we are going to say is that 0.52, which is the Kb, that elevation is caused by the molar mass, which is 342. 0.52 degrees Celsius, that elevation boiling point, it is caused by 342 grams of the sucrose. What about the other elevation of 1.7? Is caused by how many grams? Simple. So you can see it is just a matter of understanding what you need. I need grams. I have elevation, I have kb. I can get grams. So I first get my elevation boiling point, the TB, using the boiling point of pure water and boiling point of the solution. I get it as 1.7. After getting it, I come back here and say, what's the molecular mass of sucrose? 342. Therefore, Kb is caused by molecular mass. What about 1.7, which is the TB, is caused by how many grams? 0.8 grams, 1118.08 grams. Simple. So you can see how easy, how soft these questions are. You can easily get these questions, you can easily write them down. Yeah, you don't need to suffer. So you just have to understand these things, life will become very, very, very soft. Yeah. Okay, so down here, there are some other questions, or there are some questions. I'm seeing question 1 is doable. Question 2 is also doable. Question 3, it is also doable. Mm. Mm. Yeah, question 3 is also doable. Question 4. Question 4, I think it is also okay. But you just need to give it a time and read it. Yeah. You just need to give it time and read it very well. Because if you don't happen to read it very well, it may confuse you a little bit. But it is kind of doable. It is doable. Whatever we have talked about, you can easily interpret. In fact, all the questions, right from question 1, 2, 3, for all of them, they're doable. But just try out the ones you can manage, but try enough. So long as you have time. Yeah, okay. Thank you, Nawuzale. So long as you have time, uh, try out those numbers. They are not so hard. As I told you, the more you practice, the more you understand the things. But I've kept on telling you that. But some members, they don't want to practice the things. I told you, however much you'll be taught, however much you'll be discussed, however, like people will discuss for you what, if at all you don't come up and practice these things by yourself each and every day, the things will not enter the brain cells easily. The only solution for you to have these things in your brain cells is continuously practicing these things. You don't need to give up. You don't need to say, these things are hard, I won't revise them. These things are very hectic, I won't do it. Revise them, practice them, call up the calculation each and every day, continuously. The battle is still on. So right now, the thing is in your hand. You have to put in, you have to give your time to books. And those who are still having the things like that reading courage of O level. You read one statement, you read one paragraph, you feel tired, you sleep. Because you are at home, you do one number, you feel sleepy. Because you're on bed, you sleep. You can't sleep. No one is going to tell you why have you going to sleep. Please make sure, yes, you are in holiday, utilize this time well. Such that you don't come back to school when the head is empty. You already know the things we discussed them. You can still you even see that There's nothing to complain about. You already know that this topic we discussed at school. We even repeated it in the holiday, but my head is knowing nothing, has nothing. That is too bad. So please make sure you read these things, practice them. Where there is a challenge, consult. Don't stay with things you don't know, yet you covered them. Don't be there, you relax, and don't get to understand these concepts. Understand them. If you are failed to understand them right here, go back and practice. You can easily understand them by yourself when you start practicing them. Write down all those calculations we have done. Can you go back and write them and write correct steps and answers? If not, it means you have not understood. You have to practice more. So that's why you need to do these questions, because they can easily tell you that you understood the thing or the concept, or you did not understand the concept. Otherwise, practice will make you perfect. If you don't practice, things won't be so good. So I think for the case of elevation boiling point, that one we are done. Tomorrow, at least make sure you come when you have done some numbers there from elevation. But otherwise, we are done with elevation boiling point. Tomorrow we talk about the freezing point depression, and I think some osmotic pressure will be somehow speeded. I try out some few numbers. The rest of the numbers will be yours. So I try some few examples such that we go to osmotic pressure, because we need to talk about other concepts. We are in physical. I think either on Wednesday, that's when we talk about another branch, either organic or inorganic. So we also talk about that osmotic pressure briefly, because what we need right here, or what we have not talked about here, I think, is it the graphical method? I don't know whether it is even here. But even elevation boiling point has some graph work. Yeah, it has some graph work. But we are going to look at that tomorrow, the freezing point depression and osmotic pressure. Otherwise, we are going to stop our session right here, unless when there is a question from you guys within this time, you can easily ask it before we vacate. Is there any question? Any comment about what we have talked about? Okay, so if there is no question right here concerning what we have talked about, we are going to end our session right here. So I just thank you members for attending and for keeping time. So let's also keep time tomorrow. Those who came in late, let's also try to keep time such that we start at exactly 8. Yeah, or at 8, something 8 to 8, something like that. But starting at 8:20, it means we consume some time or waste some time. So otherwise, thank you for attending and thank you for participating, those who have participated. So you have a nice day ahead and another session for BIOS. Otherwise, we are stopping here. Thank you, members. Have a nice morning.
Yes, Gwyneth Tracy. Hello. Tracy? Tracy, can you hear me? Where is Tracy? Tracy? Where is Gwyneth Tracy?
Hello? Yeah, I can hear.
Where are you? I can't see you.
I can hear you.
Your
I
voice
can
is so
hear
low.
you.
Hello? Where is Tracy? Unmute, unmute. Who is Jerry Hims? Can you introduce yourself, please?
I'm here. Hello.
Jerry Hims, what is your full name? Jerry Hims? Okay, Gwyneth Tracy. Yes, Tracy. Tracy, can you hear me? Tracy.
Yes.
Okay, so
Morning, sir.
biology is next coming in at 10:40.
I can hear you.
Hello. Hello. Hello.